Wait, Amma, wait. Wait.
Okay, okay. Adoni sir, center.
Okay. So last week we principles of inclusion. Am I audible, Adilakshmi?
Yes, sir.
Okay. As last week the principle of inclusion and exclusion I told. Now that problems, now I will explain the related one. Some more problems I will give you today. The screen is visible now.
Visible, sir.
So therefore, find the number of integers from the set 1, 2, 3 and so on 1000, which is divisible by 3 or 5. So what is the solution I am writing here? Let x is equal to 1, 2, 3 and so on 1000 I am writing here. With the set of all integers, we are writing 1 to, what is the integers is 1 to 1000. We can write it or not?
Yes,
Please,
sir.
yes. Let a comma be the set of all integers 1 to 1000 is divisible by 3 and 5 respectively. Suppose we will write one a is equal to x belongs to x. X is divisible by 3. Then b x by x belongs to x. X is divisible by 5. Oh, na? So 1, 3 and 1, 5. So then we have what we are taking here. A intersection B, x by x belongs to x. X is, intersection means it is divisible by 3 and 5. Am I correct or not?
Yes, sir.
It is divisible by 3 and 5. Then union of B, intersection also taken. So x by x belongs to x. X is divisible by 3 or 5. Why? Because it is a union is 3 or 5, but intersection is 3 and 5. We can take it or not. So then by using the one set of function, we are taking here a is equal to 1000 by 3000 numbers. What is the 1000 by 3 value? What is the 1000 by 5 value?
$333.3, sir.
333. Okay, next.
200.
Very good. 300 to 333. But A intersection B is equal to 100 by 15.
20, sir.
1000 by 15, sorry. 1590, approximately 66.66. So we am taking. So x denote x, the small x is denotes integer part of x. The principle of inclusion formula of A union B is equal to modulus of A plus modulus of B minus modulus of A intersection. Modulus of A and the 333. Modulus of B and the 266. So total how much? 300, 533 minus 66. How much? Tell me. How much?
467, sir.
That is a value of A union B. Modulus of, we can write it the rate of modulus of A. It is a negative also, we can take the positive value. This is called one of the problem. So then we will go to the Pigeon hole principle. What is a Pigeon hole principle? Is also known as a Dirlecht's principle, that is called as box principle. It is also one of the methods of counting. In this principle, a large number of objects are distributed into some specified number of boxes. Then at least one of the boxes will contain certain number of objects. Here, the objects are treated as pigeons. So, and the boxes are treated as pigeon holes. So, we can call it as pigeon hole principle. What is that one? We are taking the pigeon hole principle. Whole principle form of one we can take here. Let M1, M2, and so on, Mn be positive integers. So therefore, if I'm taking here M1 plus M2 plus M3 plus so on plus Mn minus n plus 1. So this is a number of objects put in n boxes. What is a n boxes we are taking here? Neither first box contains at least M1 jobs and second box contains M2 jobs. Third box containing M3, M4 and then and up to the nth content box. What is at least, what is the jobs here? Mn jobs. So now only this one. This is only M1 jobs. Am I correct?
Yes, sir.
Then we will take the proof. This is a statement. Suppose we will take here. Suppose we will take here P. Let P be the statement. Let P be the statement I am taking here. So therefore, M1 I am writing here M1 plus M2 plus M3 plus and so on plus Mn minus 1. So number of object is distributed into how many rows? N rows. Am I correct? N rows we are distributed. So therefore, another statement we have taken, let Qi is be the statement. Let Qi be the statement I am taking here. Then ith box contains at least M1 objective we are taking here. M1 object, M1 at least M1 number of objects we can take here. So therefore, what is the formula? What is the formula here? Q. What is the symbol?
Union, sir.
No, it is in the DMS. We can write it is R. O or R.
Okay.
This is R. This is AND. This is conjunction. Okay.
Okay.
Q1, Q2, Q1R and Q2 R and so on R Qn. So we have to prove P combined to Q. P stands to Q. So therefore, assume the truthness of P and the Q. P and the Q. So therefore, Q1 and Q1R, Q2 and so on. So we take that Q or Q1 gani, Q2 gani, Q3 gani, Qn gani తీసుకుంటాం. Then immediate negation. So negation, this is a symbol. You can write what is a Q1 and Q2 and Qn. So therefore, the negation means exact of the negative value. So therefore, that is a Qi. The ith box of the contains less than M1 objectives. Then the ith Qi, the ith box of the contains M1 minus 1 objectives. The phi box contains less than or equal to Mi minus 1 objectives. So we are taking Qi, Q1, Q2, Qn, and we are taking. But the total of the number of objectives that they distributed in n boxes of we are writing here less than or equal to M1 plus M2 plus and so on Mn minus n we can take here. So therefore, the total number of objects is distributed into n boxes. We can write here M1 plus m2 plus and so on, mn minus n plus 1. So therefore we can write here m1 plus m2 plus and so on plus mn minus n plus 1 less than m1 plus m2 plus and so on plus mn minus 1. We can write it or not?
Yes, sir.
So therefore we can write 1 less than. So it is a 1 less than or equal to 0 is a contradiction. Why? Because this is not true. P and negation of Q is not true. P and the negation of Q is not true, but only P stands to Q. That is a negation means there is a true is false value. So therefore P and P stands to Q is only true. Then whole principle whole principle. So therefore a whole principle we are taking here. If n pigeons are accommodated into m pigeon holes, that is n greater than m. So at least one pigeon hole will contain two or more pigeons. So therefore n objects put into m boxes. So therefore n boxes we can write here n greater than m. So therefore at least one box will contain two or more objectives. So what is the more objectives? So therefore we can take that P1, P2 and so on, Pn be the pigeons. That is, and H1, H2, Hm is the m pigeon holes. That is P1, P2, Pn, and we can take a pigeon. That is the H1, H2 is the holes we are taking. So therefore P1, P2, Pm are assigned H1, H2, M, and respectively we can left with n minus m pigeons we are taking here. So the right one Pm plus 1, Pm plus 2, and so on, we can write Pn. So why? Because these pigeons are assigned into the m holes in the same arbitrary number. Obviously, at least one pigeon hole will contain two or more pigeons. So that's why we are separating the n pigeons as P1, P2, and H1, H2 the m pigeons we are clubbing here. So therefore, m minus 1 condition we can write Pm plus 1, m plus 2, and so on. Pn we are taking here. Then one more theorem, pigeon hole principle form 3. Now this is a pigeon hole principle form 2. Now I am telling pigeon hole principle form 3. Suppose if a pigeons are accommodated into m pigeon holes, therefore n greater than m, and then one of the pigeon must contain at least n minus 1 by m plus 1 number of pigeons. So we have to prove the using a method of the contradiction. So there each pigeon hole contains, we know that given here n minus 1 by m, it's a pigeons. So therefore the maximum number of pigeons of all m, in all m pigeon holes we can write n minus 1 by m less than or equal to n minus 1. So where this contradicts the giving the information, there are n pigeons. Why? Because we are taking contradiction method, so that's why we are writing n minus 1 m. So this is the condition of less than or equal to n minus 1. So therefore it contradicts the given information. The natural numbers 1 to 10 are arranged random around a circle. Around a circle. So that there are three adjacent numbers whose sum is at least 17. So therefore, the natural number 1 to 10 arranged in a random circle. So we can adjacent numbers whose sum is at least. Here exist 10 triples of adjacent number with S1, S2, and so on, S10. So we got why? Because 1 to 10 they have given. So each sum is less than 17. At least 7, at least less than 17. So for what we have to write? S1 less than 16. Am I correct?
Yes, sir.
So therefore I is equal. Are you understanding?
Yes, sir. I understood.
1, 2, 3, 10. So therefore S1 plus S2 plus and so on plus S10 less than 10. That means 10 into 10 is numbers is less than 16. It is equal to 160. It is correct or not?
Yes, sir. 160.
Yes. In the sum of each numbers from 1 to 10 3 times. So hence the sum is equal to up to 10 appears 3 times. So we can take here 3 of 1 plus 2 plus 10 is equal to 3 into 1 to 10. What is how much value? Tell me, calculate and tell me. Sum cheyandi 1 to 10 sum cheste ento cheppandi.
55, sir.
3 into 55. How much? 3 into 55. 165.
165.
So therefore 165 less than 160. So therefore it is possible or not possible?
160. No, sir.
Not possible. Why? Because the adjacent numbers whose is are at least 7. So therefore here given the result is it is why? Because 165 greater 160 less than 165. It is possible.
Yes, sir.
You have to check all these one. And another example.
Not is less than.
Yes, it is not possible.
Yes, okay.
Next one, the numbers, 3 numbers are chosen at random. Their sum is 19. Show that the least one number is 7 or more. So therefore, n 3 numbers. How many number of pigeon holes we will take? How many number of pigeon holes we have to take?
Don't understand, sir.
The numbers are chosen in random that there is 19. So that at least one number is 7 or more. 7 3 is how much?
21, sir.
So it is in the between 9 or there, 19 or there or not?
Yes, sir. 19.
So therefore we can take the pigeon holes, we can take 3 or not?
Yes, sir.
7, at least 7. 7, 7, 7. 3 7s are 21. It belongs to 19. Okay?
Okay.
Let k be a positive number. So therefore, kn plus 1, it is the sum of the numbers is 19. So kn plus 1 is equal to 19. Kn is equal to, what is n? What is the pigeon holes?
3, sir.
3. K is equal to how much? 6. Am I correct or not?
Yes, sir.
So therefore, the n pigeon holes are occupied by kn plus 1. Pigeon where k is a positive integer, then less than pigeon is holes is compiled by k plus 1 or more pigeon. So there is at least one pigeon hole that contains at least n plus 1 means we can write here 6 plus 1, 7 pigeons. So therefore, hence the result. Are you clear?
Clear, sir.
1 minute. Next one. A is equal to 1, 2, 3, 4, 5, 6, 7, 8 we are taking here. Prove that 5 integers are selected from random from a capital A, then at least one pair of integers has a sum of equal to 8. So therefore, we have from the 4 sets of each containing the elements is sum 9. You can write here 1, 8, 2, 7, 3, 6. We can write it or not?
We can write.
So we can select the 5 numbers from these numbers. The Pigeon principle of least 2 must be from the same set. The sum of square is 9 numbers is 19. So this is also one of the problem. We have to take the sets. Mathematical induction. Just a minute. Mathematical model induction. So mathematical induction plays an important role in mathematical sciences. There are mainly 2 types of application of mathematical induction. If n is any natural number, then any proposition or statement involving can be the value n. N we can write that is n belongs to n. So for a few different values of n, we can make some observation of particular thing. Then we can generalize the observation and prove that mathematical induction. What is the method of proving? If n is a natural number, Pn is a proposition involving n. To prove that proposition Pn is true, all n belongs to n. So we can proceed. The basis of induction. So therefore, P of n is a true when n is P of n is equal to true and n is equal to 1. Inductive hypothesis. Here we assume here truthness of Pn for some is k, for some k. And inductive step, basing on inductive hypothesis, Pk plus 1 is equal to n is equal to Pk plus 1 is equal. Therefore, true for n is equal to Pk plus 1. So this is the second and third inductive and inductive hypothesis steps. We can establish the truthness of implication P of k to P of k plus 1. We can write it or not? రాసుకోవచ్చండి.
అర్థం కాలేదు సార్.
Suppose inductive hypothesis lo we can assume the truth of Pn for some k తీసుకుంటున్నాం. Okay. But inductive step lo basing on inductive hypothesis P of k plus 1 is for true value అయినప్పుడు n is equal to k plus 1. So n is equal to k plus 1 meet the P of n is equal to n is equal to 1. ఈ both the condition ప్రకారంగా P of k to k plus 1 అని రాసుకోవచ్చు కదా.
Yes, sir. Yes.
So therefore, that is a steps established the truth of the implication. Use the mathematical induction. Show that use the mathematical induction. Show that the sum of first n natural numbers, it is n into n plus 1 by 2. So therefore, show that R therefore show that use the mathematical induction and show that our 1 plus 2 plus 3 plus n is equal to n into n plus 1 by 2 for every n belongs to n. So the given preposition is 1 plus 2 plus 3 and so on n into n plus 1 by 2. Aunama?
Yes, sir.
N into n plus 1 by 2.
Basic step, sir.
Wait. Pen padam ledu, just wait.
Okay.
Basic step. For n is equal to 1. So appudu emaitadi LH is equal to emaitadamma 1 aitadi avuna kada?
Yes, sir.
LHS is equal to 1. So therefore RHS is equal to emaitadamma 1 into 1 plus 1 by 2 avuna formula la?
Yes, sir. 1.
1 into 2 by 2 is equal to. So the Pn is true n for 1 or not?
Yes, sir.
The Pn is true for then inductive hypothesis. Suppose the preposition Pn n is equal to k, we are taking 1 plus 2 plus 3 and so on plus k. What is the formula? K into k plus 1 by 2. Avuna?
Yes, sir.
Then inductive step. Now I am telling inductive step. For n is equal to 1, for n is equal to k plus 1. One plus 2 plus 3 and plus k plus 1 I am taking here. 1 plus 2 plus 3 plus so on plus k plus 1. Raskochama?
Yes, sir.
K plus 1 by 2 of. This is the formula for k plus 1, k plus 1. So therefore k plus 1, that is a simplification, is k by 2 plus 1. Raskocha?
Yes, sir.
Therefore k plus 1 and k plus 2 by total division of multiplication 2. So therefore k plus 1 and k plus 2 by 2. So therefore true n is equal to k plus 1 here. So by the mathematical induction, the result of all values of true, then n is equal to 1 plus 2 plus 3 and so on plus n is equal to n into n plus 1 by 2. Am I correct?
Yes, sir.
Then another problem we have to do. For every n belongs to n, show that summation of I is equal to 1 to m t square n into n plus 1 by 2n plus 1 by 6. So here Show that the sum of square the first rational numbers is the formula is n into n plus 1 by 2n plus 1 6. Avuna?
Yes, sir.
Pn is equal summation of I is equal to 1 to m t square n into n plus 1 2n plus 1 by 6. We have to take here r, we have to take here 1 square, 2 square, 3 square, and so on. N square is equal to n into n plus 1 to 2n plus 1 by 6. So basic of induction, what is induction? N is equal to how much? 1. Basic of induction ఎంత 1 కదా, ఇంతకు ముందు మనం చూసాం కదా.
అవును సార్. ఎస్ సార్.
n into n plus 1 by 2 లో.
ఎస్ సార్. 1.
Basic of induction అర్థమవుతుందా?
Yes, sir. I understood.
What I am telling you are understood.
First value, summation లో first value 1 కదండి సార్.
అవునమ్మా.
Yes, sir.
అప్పుడు ఏమవుతుంది? 1 plus 1 plus 1 2 plus 1 2 3 3 into 2 6 6 by 6 1 కదా.
అవును సార్.
అప్పుడు LHS is equal to RHS కదా.
Yes, sir.
ఇంతకు ముందు ప్రాబ్లం కూడా మనం n into n plus 1 by 2 లో కూడా చేసినామా లేదా?
Yes, sir. That is also.
Yes, that is also same. Then inductive hypothesis. Inductive hypothesis. Assume that the statement for true n is equal to k 1 square, 2 square, 3 square, and so on. K square is equal to k into k plus 1 and 2k plus 1 by 6. Avuna?
Yes, sir.
What is the inductive step?
N equal to k plus 1.
Very good. N is equal to k plus 1. Very good. No? So what is LHS? 1 square, 2 square, 3 square, and so on. K plus 1 whole square. Avuna?
Yes, sir.
1 plus 2 plus 3 plus k square plus k plus 1 whole square. అంటే దీని బదులు ఇది రాస్తున్నాం. అవునా?
1 square, 2 square.
1 square, 1 square, 2 square, 3 square, k square. LHS k into k plus 1 2k plus 1 by 6 plus k plus 1 whole square. What we will take the common?
K plus 1.
K by 2k plus 1. Avuna?
Yes, sir.
By 6 by k plus 1 we are taking here. In place of k x plus 1 I am writing here. LCM I am taking 2k.
K plus 1 also.
Amma? చెప్పండి.
Above step, sir. K into 2k plus 1.
K into 2k plus 1 by 6 కదా.
అవును
అదే రాసా.
ఓకే ఓకే.
కిందికి పోయింది అంతే 6. So I am taking x here, x plus 1 by taking the LCM. What is the value? X square plus 7k plus k square plus 2k square plus 7k plus 6. So therefore we can write this is a simplification we have then write here. K plus 1. This is also k we have to write. K plus 1, k plus 2, 2k plus 3 by 6. So therefore LHS is equal to RHS true. Why? Because k plus 1, k plus 2, 2k plus 3 by 6 by mathematical induction 1, 2, 3 square n into n plus 1, 2n plus 1 by 6. So n into n plus 1, n into n plus 1, n into 2n plus 1, 2n plus 1 means 2n plus 3. That is n plus 1, that is 2n plus n plus 2 and n plus 1. So therefore this theorem of this one, the induction of step I cleared. Are you understood?
Yes, sir.
Okay, just a minute. Then the same induction, you have to do induction of hypothesis, induction of steps. I'm not going to that. Okay.
Okay.
Generating functions, recurrence relations. Generating functions and recurrence relations. So in this one, A0, A1, A2, and so on is any sequence of numbers, and X is any variable, then A of X, A0, A1X, A2X square, so on is equal to summation of is equal to 0 to an X, and we can write it or not. So then any A0, A1, A2, and so on is any sequence of the number, and X is only variable. A of X equal to 0, A1X and A2X and so on, A2X square, A3X cube, and so on. We can write here the summation of n is equal to 0 to infinity an power x, and it is correct or not?
Yes, sir.
So therefore f of x is a formal power series. A is the coefficient of xi. A of xi is the term of degree I. A0 x power 0, A0 is a constant term of A of x. Avuna kada?
Yes, sir. AIXI is the
Just wait. I will tell you.
okay.
AXI is the constant of x power I. Avuna? Xi ki constant avutunde kada?
Yes, sir.
AXI is the term of degree. Power lo degree is I. And AX power 0 is A0 is the constant term of A of x. Am I correct?
Yes, sir.
That's why I'm telling. Generating function A of x is equal to summation of r is equal to 0 to 2 power r x power r generates the sequences A is equal to 2 power r is equal to 0 to infinity is equal to 1, 2, 4, 8, 16. అవునా కదా? పవర్ లో స్క్వేర్ రాసుకుంటే 2, 4, 8, 16 వస్తుందా రాదా?
Yes, sir.
అనదాని అంతే. r plus 1 whole square రాసుకుంటే 1, 2, 3, 4, 5 and so on వస్తుంది.
Up to infinity, sir.
అమ్మా?
Up to infinity.
అప్ టు ఇన్ఫినిటీ. వాట్ ఇస్ ద వాల్యూ? మనం ఏ వాల్యూస్ రాసుకుంటే అక్కడ వరకే రాసుకుని క్లోజ్ చేద్దాం.
Okay.
మనం అప్ టు ఏ వాల్యూస్ రాసుకుంటే ఆ వాల్యూస్ తీసుకుంటున్నాం కదమ్మా.
Yes, sir.
Operations on generating of operations on generating function, building generating function. So therefore A of x, A0 plus A1 plus A1x square, that is summation of r is equal to 0 to infinity ER x power r. Avuna?
Yes, sir.
So therefore B of x is equal to, we are writing here B0, B1x b to x square. So on summation of r is equal to 0 to infinity brx power r. Avuna?
Yes, sir.
So therefore, by any two generating functions, then we can define uniquely equality. So scalar sum, scalar multiple.
Completed, sir.
B of x is equal to b0 b1x and b2x square summation of r to 0 infinity b power n or n power x power r. So therefore, be any two generating function with the define of the quality sum means addition, scalar multiple, product, multiplication, right shifting, derivative of generating functions. What is the equality? So what is the equality here? The two generating function a of x and b of x are equal. The coefficients of the generating functions are equal. Why? Because we have to write here a of x is equal to b of x is equal to a n is equal to b n. We can write it or not?
Yes, sir.
A n is equal to b n for every n. So scalar multiplication. What is the meaning of scalar multiplication? So scalar means what we are taking k a of x is equal to, we can take the common of r is equal to 0 sigma a n x n summation of r is equal to 0 to infinity k a n x n. We can write it or not?
Yes, sir. We can write.
Right. What is the sum? Tell me. A of x plus b of x. We can write summation of infinity to n is equal to 0. Summation means a n plus b n of x power n. We can write it or not for sum?
We can write.
What is the product? Just multiply. Avuna kada?
Yes, sir.
And a n.
A n into b n.
No. b n to bx is equal to summation of n is equal to 0 to infinity p n x n. So therefore p n is summation of j plus k is equal to n infinity aj bk, that is a of x and b of x is equal to, we can write the multiplication in the product of multiplication. We can write here a0 b0 x power 0 a0 b1 a1 b0 x power minus 1, sorry, x power 1 plus a0 b1 a1 b1 a2 b2 x square and so on is the multiplication we are doing here. a0 bn a1 bn minus 1 plus a2 bn minus 2 and so on an b0 x power n. We can write it or not? Why? Because a0 b0 a0 b1 a1 b0 a0 b1 a1 b1 a2 b2 and so on. We are shuffling and we are multiplying the product. We can do it or not?
Yes, sir.
Yes. Adilakshmi, we can do it or not?
Yes, sir.
Okay. So now derivative rule. What is the derivative rule? We have learned. Then we'll go to the problems. If a of x summation of n is equal to 0 to infinity an k power n, that is we can write a0 a1 x and a2 x square and so on plus an x power n is the given generating function of the derivative a of x. We can write here a dash x is equal to d by d power n of a xij, that is summation of n is equal to 1 to infinity n, that is a differentiation. That is a differentiation means x power n minus 1. So that is maybe written as a1 plus 2a2x and 3a3x and so on plus n x power n minus 1. Avuna? d by df of axj అంటే ఏం రాస్తామమ్మా? ఇచ్చిన ఈక్వేషన్ n into what is the 3x square అంటే ఏం రాస్తాం? 6x power 3x cube ఉందనుకోమ్మా. 3 అంటే 9x square అని రాస్తామా లేదా?
Yes sir. 3x square ని
3x cube అమ్మా.
3x cube. Okay sir.
అంటే ఏం రాస్తాం? 9x square రాయమా?
Yes sir.
9x square of into x power n minus 1 రాస్తున్నాడు. a1 2x అది రాసుకుంటూ పోతున్నాడు. అవునా కదా?
Okay.
To take each non-zero coefficient, then building generating function also same. a1x and a2x and a3x and nx can be interpreted by the number of non-negative internal solutions as e1 plus e2 and so on plus en is equal to r. So e1 is equal to the coefficient of x power r. Therefore a1x and a2x and anx. So therefore we are writing this one. Find the generating function for the number of non-negative integral solutions we have to take here. e1 plus e2 plus and so on plus en, where we can write 0 less than e1 less than 3, 0 less than e2 less than 3, 2 less than or equal to e3 less than or equal to 6, 2 less than or equal to e4 less than or equal to. ఎందుకు రాయాలి ఇలా? హౌ వి కెన్ అందుకు రాయాలి ఇలా చెప్తావా? e1 e2 to en అంటే ఎన్ని ఇచ్చినాడు? ఫైండ్ ద నాన్ నెగటివ్ సొల్యూషన్స్ ఎన్ని వస్తాయి? 0 to 3 is less than 0 to 3 e2 లో, దెన్ e3 లో 2 to 6, e4 లో 2 to 6 అంటే 0 to 4 అయిపోయింది. 2 3 4 అయిపోయింది. 5 is odd or not? 0 5 is odd or not?
5 sir.
5 అనేది ఆడే కదమ్మా.
Yes sir, 5 is odd.
ఇప్పుడు 2 కు 6 లెస్ దాన్ అవుతుంది, 2 కు 6 లెస్ దాన్ అవుతుంది, 3 లో 4 లో 5 అనేది ఆడు, బట్ 1 to 9 అనేది మాత్రం ఆడ్లోనే ఉంటుందా లేదా?
Yes sir.
That is the one. So this is the given problem. Now I will give you the solution. So with the constants and the variables we building 5 generating functions. So therefore a1x 1 plus x square plus x cube. రాసుకోవచ్చునమ్మా?
Yes sir.
Second one 1 plus x square plus x cube. This is prime. This is the same. Okay. a3x. a3 అంటే ఏమొస్తుందమ్మా? x square x cube x power 4 x power 5 x power 6. a power 4 అంటే ఏమొస్తుందమ్మా? సేమ్ ఇక్కడ రాసాం చూడు, మనం 3 4 సేమ్ రాసామా లేదా?
Yes sir.
అంటే ఇక్కడ ఏమవుతుంది? x square x cube x power 4 x power 5 x power 6. Just a minute. So x square x cube x power 4 x power 5 x power 6. a5 ఏమైతే చెప్పమ్మా? a5 ఆడ్ నెంబర్ కదా, x power 3 x power 5 x power 7 x power 9. అవునా కదా?
Yes sir. Odd numbers.
ఆడు ఈవెన్ ప్రైమ్ రాసుకుంటూ పోయినాం. అవునా కదా?
Yes sir.
So the required generating function is So a1x and a2x and so on a5x. So therefore we can write 1 plus x square plus x cube whole square, then x square plus x cube plus x power 6 of whole square. This may be written as x square plus x cube plus x power 4 plus x power 5 plus x power 6. Then odd number x plus x cube plus x power 5 plus x power 7 plus x power 9 of x. So therefore, the number of non-negative integral integrals given the equation. So the coefficient of x power 1 is a1x and a2x and a3x and a4x and a5x. So the coefficient of x power r in right hand side of x. Clear? Adilakshmi, clear?
a1x కు మీరు హోల్ స్క్వేర్ పెట్టినారు కదండి సార్.
ఒక్క నిమిషం మళ్ళీ స్క్రీన్ షేర్ చేస్తాను, ఒక్క నిమిషం ముందు. ఎక్కడమ్మా?
1 plus x square plus x cube whole square.
అవునమ్మా, అవును. ఎందుకు పెట్టాము? వీఆర్ గివింగ్ ద స్క్వేర్స్ కదా. వాట్ ఈస్ దట్? ఫైండింగ్ ద ఫంక్షన్ నాన్ నెగటివ్ ఇంటిగ్రల్ సొల్యూషన్స్ తీసుకున్నప్పుడు a1x స్క్వేర్ a2x స్క్వేర్ తీసుకొని కింద ఫస్ట్ a1 x స్క్వేర్ గా తీసుకుంటాం, తర్వాత స్క్వేర్ ని తీసుకొని తర్వాత ఈవెన్ ఆడ్ ఫంక్షన్ సపరేట్ చేస్తున్నామ్మా.
ఓకే ఓకే
ఓకే
ఓకే ఓకే అండర్స్టూడ్.
ఇంకా ఎనీ మోర్ డౌట్స్?
నో నో సార్.
సో tomorrow we will discuss this unit will complete, and tomorrow we will go to the recurrence relation. Okay.
Okay sir.
Tomorrow you can join recurrence relations, we can complete, and day after tomorrow also we can go to the graph theory, graph basic concepts, and what is that, the 7th unit, graphs, basic subgraphs, Euclidean and Hamiltonian graphs we can tell you. Okay.
Okay sir, is it first class in discrete mathematical structure?
No, this is the 5th class.
5th class. Okay.
That's why I'm telling 5th unit. There is only 3 remaining classes is there.
Okay okay sir.
Okay.
Okay sir.
Right.
Thank you sir.
Right. Are you understood?
Yes sir, yes sir.
Okay.
Sir, is there any PDF you have, sir?
I will send you of the last day of the class. Saturday you will give me the mail ID. I will tell you. I will send you.
Okay okay sir. Thank you sir.
Adilakshmi, you are any asking?
No sir. Last classes I missed it, sir. That's why I'm asking you.
Okay. No, don't worry. I will send it to PDF. Okay.
Okay sir. Thank you sir.